All right, guys, it's time for another episode of Swift Deep Dive. And in this lesson, we're going to cover a lot of the things that we've come across in the previous lessons when we were building out our app. And we're going to talk about them in a little bit more detail. So the first one I want to talk about is the Swift constant. And the reason why I have a bronze elephant here is because recently I went to a bronze sword making workshop where you get to cast your own bronze sword from melted tin and copper. Now, the reason why I'm talking about bronze in a programming class is because, similar to constants, once you've cast the bronze, it's actually very hard to change it. It's not like iron, which you can hammer and reshape. Bronze is really hard, and it's just going to stay as the shape that you've cast it. And if you wanted to change it, then you would have to melt it down and recast it. So similarly, constants, once created, they don't change their values. So if we think about the last time when we had a Swift deep dive, and we talked about this analogy of a variable being a box that contains data with a label on it so that you can refer to it later on. Well, a variable is kind of like a box with a lid on it. You can take out the value and put in a new value and change it as much as you wish. But a constant is different. A constant is kind of like a box which you tape shut and you can never ever change what's inside again. And creating a constant is no different from creating a variable. All we do is simply change the keyword. So instead of a var for variable, we create a let for constant. Now, the reason why it's called a let is because Swift, when it was designed, was intended to be a very human readable programming language. So the idea is that you would say, well, let Angela equal 0784236, etc. So it sounds like you're creating this thing and you're keeping it constant. And indeed, if you go into your playground and if you create a variable a and you set it to equal 3, well, that's the initial stage. That's like building the box, putting the value in. And then you can tap into the value inside by simply using that reference, that a, to use the value. In this case, I'm printing the value. But I can also vary the value, right? So I can say a now equals 5. Now a has been reassigned to hold a different piece of data. And when I print a at this point, it's going to show 5 instead of 3. Now, if I had changed that keyword from var to let, where I'm creating now a constant called a, well, now I get an error because I can't assign a new value to a because it's a constant. And so my program crashes and I'm not allowed to continue. So why do we have constants and variables? What's the point? Well, part of it is to do with efficiency. Because if you create a constant, the computer knows that the piece of data that it has to hold is never going to change. The contents of that box will never change. So it can store the data more efficiently. For example, if I sent you to the market and some days I asked you to buy 5 loaves of bread, but other times you only need to buy 1. Well, in this case, you might bring a large shopping basket with you, just so that you can adapt to this flexibility, right? One day you might need to buy a lot and put into the basket, and the other day you might not fill your basket at all. So that's a variable. But if you knew that every single day you needed to get 2 loaves of bread from the market every time, then you would bring a container that's perfectly sized for the job, so you don't have to carry any extra weight. So similarly here, if I create a variable a, at the beginning it might be storing a single number, right, which doesn't take a lot of space. But if at some point down the line you needed to store a much larger number in that variable, then that initial container, that box that gets created, needs to be large enough to allow for this future flexibility. Now, had this been a let constant, however, well then you only need to make a container as large as it needs to store this single value. So it's a lot more efficient. So that means that when you want to store a piece of data and give it a reference, and you know that that data is never going to change. Say, for example, you wanted to store the value for pi, right? And it was 3.14159. Well, pi is not going to change between today and tomorrow. So you could create a constant for it, right? Whereas if you had a user score, for example, well, that's constantly going to change. Every time they get a new point, then that score is going to be changed to a new value, and you can't use a constant. So by default, try to make everything a constant unless you need to change it. Now, the next thing I want to talk about are some of the most commonly used basic data types that you see in programming. Now, we've already seen a couple of data types in our programs. For example, whenever we print a piece of text to the debug console, we're creating a string. Now, a string is short for a string of characters. So just like you would have a string of pearls to create a necklace, you can have a string of characters to create a piece of text. Whereas we would normally call this text, in programming, we often call it a string. And you can tell that something is a string because when we create it, we usually put 2 quotation marks around it to tell our code that this is just text and this is not code, so don't interpret it as code. The next data type that we saw in the last lesson was the int, which is short for integer. Now, an integer in mathematics refers to a whole number. It doesn't have any decimal places. So 12 or 34 or 1239, these are all integers. And integers can also be negative as well. It's not limited to being a positive whole number. Now, what if you needed some decimal places? What if you were calculating something that needed a greater level of accuracy than a whole number? Well, you could use something called a float, which is short for a floating point number. And of course, that floating point refers to the decimal point. Now, if you needed a greater number of decimal places to have greater accuracy, say you're creating some sort of scientific calculator and you need to give people, say, 600 decimal places, then you might want to consider using a data type called a double. The reason why it's called a double is because it has double the amount of accuracy of a float. So it can hold more numbers after the decimal place. And if we were storing pi, which of course goes on until infinity, then we can have a much more precise calculation with our pi that has a double data type. Now, the final primitive or basic data type that all programming languages use is something called a bool, which is short for a boolean. And a boolean only has 2 possible values, true or false. That's it. Because often in programming, you'll need to check if something is true, in which case you should perform some sort of action. Otherwise, or if it's false, then perform some other sort of action. So in the Swift cheat sheet, if you have a look at the red block here, we've got all of those data types that I've talked about just now, plus some extra ones that we're going to learn about later on. And I've got some example values on the right so that you can quickly remind yourself if you need to see what kind of values these data types refer to. That's a quick handy tip. Now, the final thing I want to talk about is randomization in Swift. In nature, there's a lot of randomness. The pattern of leaves falling from trees, or the way that rain droplets fall on the water, these are all pretty much random events. Now, in a computer though, where it's essentially just a bunch of switches, a bunch of ones and zeros, ons and offs, it's a highly controlled environment where there really isn't much randomization. So how are random numbers generated from a computer? Say previously when we generated our random numbers, how does the computer even do that? Well, if you're curious about that, have a look at the course resources page where there's a link to a really good video on Khan Academy where Britt Cruz explains how random numbers, or rather pseudo-random numbers, the randomness that we get from computers, are generated. And it's a really, really fascinating video that gives you a lot more background on this topic, if you're interested. Now, in our project, we saw that we could generate random whole numbers by using a functionality of the integer data type. So we wrote int.random, and then we provided a lower and an upper bound. Now, in this case, what we get are random numbers anywhere between the lower and the upper bound, and including the upper bound. So if we create a new constant here called random number, and we assign this reference to a new random integer between 1 and 3. And notice that there's 3 dots in between those numbers. You can separate these out if you find it easier to see this way. But this is what we call a closed range, because when I hit print, my random number that we printed will be a whole number between 1 and 3, but inclusive of 1 and 3. So I might get 1, I might get 3, I might get 2. So if I stop my playground and rerun my playground, then you can see that I'll get different random numbers. But I've already traversed all 3 numbers, 1, 2, and 3. So all of the numbers in this closed range are possible. Now, just now you saw me use a closed range, and that refers to something called a range operator in Swift. For example, the 3 dots that we used would be known as a closed range operator, where the range is inclusive of the upper bound. But Swift also has a half open range operator, and this is done by using 2 dots and a less than sign. So this defines a range between the lower and the upper bound, but not including the upper bound. So if I change that last dot to a less than sign, then you can see that I get 1 and 2 occasionally, but I will never get 3. If I wanted a different type of number to be generated, say if I wanted a random floating point number, then I can simply change the data type at the beginning to a float. We can change that int to a float, and we will start generating random numbers with decimal places. And in this case, because it's a closed range, it could include 1.0000 all the way up until 3.0000. But if we change this to a half open range, then you can only get up to 2.99999 recurring, and you will never get 3.0000. So just by changing that data type at the beginning, you can determine what type of random number you get. And this works for Booleans as well. But of course, Booleans can only be true or false, so there's no range in this case. Now, we saw in the last lesson that we can get hold of a random element from an array by asking for a random element from our array. But you can also use a shuffle method so that the items in the array change their positions in the array completely randomly. And we're going to be using this in a later lesson as well. Now that you're well versed with randomization and variables and constants and arrays, well, it's time for another challenge. And the challenge is to create a password generator. So here we've created an array which has all of the letters in the alphabet, and each of them are stored as a string, so with quotation marks around them. And there's a total of 26 letters in the alphabet. Now I want you to write some code to randomly pick 6 letters out of the alphabet to create a random 6-character password. Now it's important to note that you can combine different characters together by simply using the plus sign. So here, if I create a constant called password, which is made up of the character A plus the character B, then when I print this password, then you'll see what prints is A, B. The strings are combined together with no space in between. And in programming, we call this concatenation. So just putting them right next to each other. And you do that using the plus sign. So coming back to our challenge, can you create this 6-character password, which is a random bunch of characters from our alphabet array? Once you've completed this challenge, then it's time to head over to the next module and create an app all by yourself based on what you've learned.